Hey guys, it's me, Adi, from the FLL team called the Ninjabots. Today I'll be explaining our team's wall code. In case you didn't know, our team has a large wall onto our robot, which can go left and right and up and down. On the wall, we will be attaching attachments to help us complete the mission. Anyways, let's get right into the code. So before I start, I just want to let you know that there are two parts of this code. The first part of this code is the wall of movement, which actually moves the robot, which actually moves the wall. The second part of this code is the wall reset, which makes the wall go back to its original position, basically a reset. So to move the wall, we'll first input two different numbers. One for moving up and down, which I named Y, and to the left and right, which I named X. So let's pretend I inputted 5 for X. That means that the wall will go halfway on our beam to the right, as we made the complete wall motion out of 10. If I inputted -5 for X, it'll go left halfway on our beam. So if you want to go 3/10 of the way up or down of the wall, you input 3 or -3 for the Y input. The second part of the code is the reset. There are two types of reset, the force reset and a smart reset. The force reset will make the wall go back, -10 for both X and Y. So if the robot is at 1 and 1 and we do a force reset, it'll go back to 0, 0 and it will just grind against the beam since it can't go anymore. A smart reset is a reset in which it checks the wall's position and it goes back that much. If the wall was at 7, 5, it'll go back 7 and back 5, making the wall 0, 0. The smart reset is, as it seems, the better option in most cases. Okay, so let's finally actually get into the code. So first, the user inputs X or Y. And at the beginning, I just split the code into two parts, X and Y. So old X will go up here and old Y will go up down here. So if you don't know how I did this, so if I just take this out, for example, you can just drag one here and make sure it's blue, and then just drag another one and make sure it's blue in. So I'll power both of these at the same time. Anyways, so they of course are just the exact opposite of each other. They're the exact same code, so I just copy it and paste it and just change the variables. So right now I'll just be explaining X. So first I created a variable named wall X. So whatever they inputted for X, I'll just set that as wall X because that's how much I need to move. Wall current X is just how much X is right now, and I needed to create this variable because I need it for the reset so I can go back. I'll explain that more into detail later. So right now, I made wall current X, and I made another variable wall X before. So whatever wall current X is right now, I'll just name that wall X before. And then after that, I just updated the value of wall current X, which I added wall current X plus wall X to find what the wall will be. Pretend, let's say wall current X is 3, because pretend they ran the code earlier and they inputted 3, and they inputted another 3. So 3 plus 3 is 6. So now wall current X will be 6. And wall X before, since wall current X was 3 before, now this will be 3. I'll show you why I created this variable in a second right now. So right here, I'm checking if wall current X is greater than 10. Now the reason I did this is because first I want to check, pretend I'm at like 8, and then they inputted 3, which is 11, and the wall can't go 11 since the max is 10. So if it is greater than 10, then what I thought of is just make the wall go to 10 and just stop it from there. So now see this wall X before which I created earlier? So I subtracted that from 10 to find out how much I need to move. So 10 is the maximum, and wall X before is what the wall was before running this code. Remember, in this case it was 3. So 10 minus 3 is 7. So it just needs to go 7 more. Now another thing is, our beam, we found out, is to go across the whole beam you have to do 660 degrees. So if you just want to move 1/10 of the beam, you just go 66 degrees. So I just multiplied whatever how much you need to go by 66 and just inputted that into our motor. And now wall current X, what X will be now is just 10, obviously. Now the second part is if wall current X is not greater than 10, meaning it's less than 10, which is good. So that means whatever wall X is, how much they wanted us to input, we just multiply that by 66 to find the degrees and just put that into the motor. And it will just run it and make the wall go however much the user wanted it to go. So I hope you got that. That was a little bit hard to explain and you may not have understood, but just try looking at this code and try just replaying the video just to make sure you understand. So now I just did the same thing for Y down here, so I don't think I really have to explain that too much. So now let's just get into a wall reset. Okay, so now the second part is the wall reset. So just a quick recap, the top part is just the force reset, and the bottom part is the smart reset. The force reset will just force the robot to go back to -10 and -10. Now this isn't always the best case because first of all it takes a lot of time, and second of all it may actually damage the robot as it's grinding against the beam that's making the wall move. So now first the smart reset is just the current position of the wall, and we just make it go back by that much, which is better. But sometimes a force reset is always necessary. Okay, so now what I did for an input was a true or false scenario. So now first, if the user inputted true, that means they want to do a force reset. So quickly just do a force reset and exit and just stop running the code. The second part is the false, which is what I'm kind of going to be explaining today. So if they inputted false, that means they want to do a smart reset. So now first we check the current position of X, and we multiply that by -66, which means we want it to go backwards. And the second part is current of Y. And now you may be thinking, why is this positive? So now I forgot to explain in the last part, which is right here. We made it when you run negative, then it'll go up, which is kind of a little bit weird. But yeah, so that means if you want to go up, you have to do it by negative, which is what we did here and here. But if you want to go back down, that means you have to do it in a positive. That's why we put a positive here. So whatever current Y is, we multiply that by 36, and we input it there. So now, because, now you may be thinking, since it's like you guys are using the same beam, which we are, so what happens to it? So, now the reason it's different is because we're using different motors. So for this one, for moving X, which is left and right, we use a medium motor, and for moving up and down, we use a large motor. That's why the degrees are different. So we need to go -360 degrees up from 0 if we want to go to the maximum position, and 660 for X if you want to go to the maximum position. So I hope you guys understood that. So anyways, we just put a Y and input it at here, just multiply that by 36 and put that as the degrees. So now the motor power for every single block is always 50, as we found that there was a good speed. It's not too slow and not too fast. It was just right. Now these last two blocks are just making wall X and wall Y 0. That is what their position is right now. So I hope you guys understood that. It's a little bit complicated, and I don't think I explained it the best. But yeah, that was really it. That was a wall reset, and this was the wall movement. I hope you guys enjoyed. Thank you for watching, and see you guys later.
Here's our robot, and as you can see, our robot has, the thing unique about our robot is that it has a wall, and this wall is able to move up and down due to this large motor that has gears. So Sharp will demonstrate the movement before we talk about it. This is going up, and this is going down. So as you can see, when it goes up, the thing, you can extend an attachment higher up. So because a lot of the missions that are on the mat deal more with height and length rather than like width in general and like space. So that's why we also made a robot more compact and more efficient in height.
2 minutes ago, one of my teammates explained that we had a left to right motion in the robot in our code. The reason we didn't put this on our robot is because it is not vitally important, and mainly we should focus on the up and down because the left to right can be used by the wheels. So therefore, we haven't included left to right. But in case you want to be more accurate, you should always put left to right.
So now for the compactness of the robot. Our robot this year is much smaller than our robot last year, because last year we had a larger mat. We had missions that dealt with larger robots, and this year we don't need as much of a larger space because it's more confined and compact. I don't know if you noticed last year, but a lot of people, they brought in super large robots that basically covered the entire mat. And so basically what would happen is that they would be able to do 4 missions at a time. So this year they probably wanted to make it more smaller for robots.
Yeah.
And
thank you for watching this.